Hello, everyone. Wow, crowded. Well, I'm kind of amazed and want to welcome all of you to Upfront and to What the Fest. Yay! So, are you awake? Yeah? Wow, I like that. Okay, let's start. My name is Gasidlo. I'm a developer for more than 10 years now. I am a core member of Hoodie and co-organizer of Open Textbook Conference and Reject.js. You might attend to that. Yay! So we see each other. And today I would love to talk about workers, web workers, and service workers. And first I will explain to you what a worker is and why we actually need them, and what types of workers are there. Also, how to let the worker actually work for you. And at last, we take a special look at the service worker. So let's start. So letting the web work for you sounds actually great. But what is a web worker actually? The web worker was introduced with the HTML5 specs and is a part of the standard now. It runs predefined JavaScript scripts in your browsers. The support is pretty good, like you may see here. And it is supported by all major browsers, except of Opera Mini, but yeah, well, shit. Yes. Gotcha, also. This is what happens, actually, when you run too many scripts. Your page gets like super slow, and sometimes the scripts even get stopped by a timeout. And this is like the worst case. You might saw that before. But sometimes you need to do stuff like, for example, loading a huge pile of JSON, like a huge JSON file, or running a killer algorithm on some numbers, or preload sets of data. So imagine a site that needs to handle UI events, queue and process large amounts of data, and manipulate the DOM. It's pretty common, right? You should all know that. You can interact. You can. You're alive. You're awake. Unfortunately, all of that can't be done at the exact same time. So due to limitations of in the browser JavaScript runtime, script execution happens just single-threaded. So this means a huge front-end logic can actually block your whole application. Developers love to mimic concurrency. Async events are processed after the current executing script is done. Async, but non-blocking requests doesn't necessarily mean concurrency. Workers utilize thread-like messages passing to achieve parallelism. They're perfect for keeping your UI refreshed and performant and responsive to users. So we have an application, and like you see, it's a very happy one. The moment you need to add like a huge task like pulling a huge pile of data, you might run into a timeout. So what do you think? What is a normal timeout in the browser? Just raise your hand and take a guess. What do you think? Like a completely normal timeout in the browser. 30 seconds, okay. Anyone else guessing? 10 seconds, okay. Anyone else? A minute, okay. Last one. 2 minutes, okay. Actually, it's 80 milliseconds. 80. And this is the point where you should start thinking about using a worker. 50 is like the common default, and 30 milliseconds for mobile. So the web worker specs defines an API for spawning background scripts for your web application. And it allows you to do things like fire up long-running scripts to handle intensive tasks, but without blocking the UI or other scripts that handle user interactions. The web worker thread runs their code from top to bottom and then enter the async phase, in which they respond to the events and timers. So you can still interact with the application like you normally would, but outsource like the heavy operations. And if they fail or get a timeout, your application is still up and running, which is actually nice. So sounds awesome, right? Cool. So what do we actually use workers for? encoding and decoding large strings, complex mathematical calculations like prime numbers, encryption, simulating leading, etc. Prefetching and or caching data. It's nice. Cool. There's more. Network requests and resulting data processing, especially processing like large arrays or huge amounts of JSON data. Calculations and data manipulations on local and session storage. Yes, totally. Image manipulation. Yeah. And more. Code syntax highlighting or other real-time text analysis, spell checking, or real-time search. Background analyzing and processing video and audio data, like face and voice recognition, totally. Background I/O and polling web services. I'm sure you found already more than 2 use cases, right? Who did? Nice. So you fell in love, right? Even the sky has the limits. So let's take a short look at what the worker can't do. Well, they can't access the following. Vendor object, document, parent object, so no access to page scripts or global functions. So this also means you can't use libraries that depend on these objects like Node.jQuery, Angular, React.js, not right now. Upcoming React.js version won't rely on the browser, but still ask yourself if you really need to do that. And you can still use this stuff for UI, don't get me wrong, but not in the worker, actually. Bummer. What can we actually do? Because web workers have a multi-threaded behavior, they only can access a subset of JavaScript features. So we can access the navigator object, use the read-only location object, execute the XHR to send HTTP and HTTPS requests. Keep that in mind for later. We'll need that. And set a time or interval for an activity. Access the app cache. Keep in mind for later. Still need that. Import external scripts and spawn other workers. So, still lots we can use. So let's start. Basically, workers are like these amazing little helpers that you can spawn when you can pass some work. And when done, you get back a result. And you can spawn as many workers as you like, but be careful. They do not block your eye, but they use a lot of CPU. So it basically can freeze your whole computer, so it freezes all. And you know how coded minions, busy workers can get? So there are 2 types of workers, dedicated and shared workers. Dedicated web workers are linked to the creator. So this means the creator is the script that called and loaded them. Shared web workers allow any number of scripts to communicate with a single worker. They are identified in 2 ways, either URL or by name. And when we talk about web workers, and mostly all of the tutorials, when they talk about web workers, it's normally dedicated web workers. So, in order to find out if we can use web workers, we need to check if their web worker property is on the window object. So, if not, doesn't support it, you get undefined and you will be fine. And web workers run in an isolated thread. So, as a result to the code, they execute needs to be contained in a separate file. Okay. So the first thing to do is to create a new worker object in your main script, and the constructor takes the name of the worker. If the specified files exist, the worker will spawn a new worker, which is downloaded async, and it will not be gone until it completely has downloaded, and then it will get executed. If the path of the worker returns a 404, it will fade silently. Silently. Thank you. So, we don't have very much time today, so I put online the slides. We're not done yet, don't be scared. This is a really nice demo you can check out, and also a lot of code snippets you can check out for the web workers. The thing you need to know is that workers don't run locally, so you have to enable cores. Keep that in mind. So we've talked about the worker. Now let's take a focused look on the service worker. The offline first concept became one of the most important ones to follow. Like Jack Audible got it right the other day. Offline first means getting on screen without a network request. The more that it's there before the network, the more offline first it gets. So this means every web application should work without connection after the first visit and just use the network for getting and setting data. Everything else is online first. Cool. So why not app cache? You might ask yourself, so why not handling everything else with app cache? Well, we already know app cache is a douchebag, has a lot of issues, and we need to handle. So the major issue with app cache is not just the numbers of gotchas you have. The design works really well for single-page web applications, but not for multi-page sites. So the service worker is like the new browser feature that provide event-driven scripts that run independently of web pages. It's a programmable proxy, network proxy, which allows you to control how network requests from your page are handled and help developers to build URL-friendly, always available applications in a sane and layered way. But why can't we use the web workers for that? The difference is, with service workers, you can fetch your assets and serve them from the caches, so we can replace the app cache. On top of that, we still can outsource the heavy operations, like pulling the huge pile of JSON. Imagine. On your page requests, your page requests something new. So the request gets through the service worker, then to the network because it's new, and this network serves back the response to the page and to the cache. Because the service worker told the cache to fetch the response. It's really great for assets. And here we have the same use case, but the service worker knows we already stored the requested assets or data and in the cache already. So it serves straight from the cache, which serves us a lot of time and resources. You also can add the behavior. It should go to the network and check if there's an update available. Cool. And it saves a lot of time and requests because you are able to control the whole behavior. It's everything on you to decide how you want to handle that. And one more feature, how it saves resources, is unlike other workers, service workers can be shut down at the end of events, which is awesome. It will be terminated when not in use and restarted again next when needed. You can't rely globally on the global state with the service worker on fetch non-message event handlers. If there's information that you need to persist and reuse across restarts, service worker to have access to IndexedDB API. So you can use that. Service worker also have scriptable caches. Along with the ability to respond to the network requests from certain web pages via script, this provides a way for applications to just go offline, which is neat. And service workers makes extensive use of promises. So you should be familiar with that before you start using service worker. And I would love to show you the service worker lifecycle because it's a little bit different. To install service worker from your site, you need to register it, like we've seen before with workers. So constructor, register, done. Registering a service worker will cause the browser to start the service worker install step in the background, which you can see here. Typically during the install step, you want to cache some static assets. Pretty common. If all the files are cached successfully, then the service worker becomes installed. If any of the files fail to download and cache, then this install step will fail, and service worker won't activate. But no worries, we'll try next time, so it's fine. When we're handled, the activation step will follow, and this is a great opportunity for handling any management of old caches, which is really good. After the activation step, the service worker will control all pages that fall under the scope. The page that registered the service worker for the first time won't be controlled until it's reloaded again. Once the service worker is in control, it will be in one of two states. Either the service worker will be terminated, saving memory, or it will handle fetch and message events, which occur when a network request or a message is made from the page. So, service worker is still in development, but pretty far in progress already. If you want to check it out, is service worker already ready? It's there. And there's also the offline cookbook, which explains everything and how the best practices to it are. So you can dive deeper there. Written by Jake. Awesome. Yeah. And now you know it all. And I would love to give over to Louis. Thank you very much.
Thank you, Ola. That was amazing.